Okay, welcome to lecture 5.5. Okay, let me take each of these terms. So I want to simplify those. The first one, this term just equals the probability that I votes yay yay. Okay. 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 Probability I votes yay yay equals probability his ideal point is less than 3.025. Okay, so that is zi transpose gamma plus epsilon I less than or equal to 3.025. Okay. Now I want to get that, turn that into, let's see, that equals, let's get the epsilon to one side. That equals probability epsilon I is less than 3.025 minus zi gamma. Okay, now I want to, remember epsilon I is normal. I wanted to express this as a function of big phi. Okay. Now remember, big phi is the standard normal. Okay. Epsilon I is not distributed standard normal. Remember, standard normal has a variance of 1. Epsilon I has a variance of sigma squared. Okay. How do we transform epsilon I into a standard normal? We just divide by the standard deviation. Okay. So if we divide both sides by sigma, the same probability is true. We haven't changed the probability term. Okay. Once we've done this, now epsilon I divided by sigma is standard normal. That term has a variance of 1. Okay. So that just equals phi of 3.025 minus zi gamma all divided by sigma. Okay. All right. So that's probably the easiest one. Let's look at the second easiest. Second easiest is probability I votes nay nay. Okay, I'm going to do this third one here. Okay. Okay. Probability I votes nay nay equals probability zi gamma plus epsilon I is greater than 3.10. Okay. That equals probability epsilon I is greater than 3.10 minus zi gamma. Okay. This equals 1 minus the probability epsilon I is less than that. Okay, so that equals 1 minus probability epsilon I less than 3.10 minus zi transpose gamma. Okay. Now, let's do the same trick. If we divide epsilon I by sigma, do that on both sides, we now have a standard normal random variable. Okay, and then we can use the big phi. So let's divide by sigma on both sides. So now that's standard normal. So then all of this equals 1 minus big phi of this term. 3.10 minus zi gamma, all divided by sigma. All right. Now, the last thing to do is probability I votes nay, yay. Okay. Now, our theory says with probability 1, you're going to vote one of those three ways. Okay. We said that the theory rules out the case of yay, nay. So these three terms, whatever we write here, this term plus this term plus this term, has to sum to 1. So this term just equals 1 minus these two terms. Okay. So this equals 1 minus this. Okay. The 1 is 0. 1 minus 1 is 0. Minus this term changes the negative sign to positive. So this is going to be just phi of this, 3.10 minus z I gamma divided by sigma, minus this term, minus phi of 3.025 minus zi gamma, all divided by sigma. Okay. So that is it. Okay. So all we have to do now is just, we've got the three terms. Here, I'll tell you what, I'll circle them in orange. So we've got three terms. This one, and this one. All we have to do is take those three terms, substitute them into here, and then that's the likelihood function. Okay. Once we do that, all we have to do is say maximize the likelihood function, choose gamma, sigma. By the way, I defined it theta 1, theta 2, and theta 3. We don't have to estimate those because we've just assigned those values. We said theta 1 equals 2.90, theta 3 equals 3.15. Gosh, I can't remember these things. Yeah. And then theta 2 equals 3.05. And we did that just by reading the bill. That's how we get the thetas. Okay. So all we have to estimate, remember, and then the zi's, that's a vector of independent variables. All we have to do is estimate the gammas, the vector of gammas, and sigma. Okay. So that's all we have to do. Program R to optim, use whatever function you want to get those values. Okay. One issue, though, let's think about, and are there any identification issues? In particular, is sigma identified? Okay. And remember, in probit, it would not be identified. And the reason why is because let's see, what am I going to do? I'm going to use red. Before, what we did is we picked some constant and say 0.7. And if we multiplied all of the parameters by 0.7, then the likelihood function wouldn't change. That's what happened before. So let's see what happens if we do that. So multiply sigma times 0.7, this gamma times 0.7. Okay. And then before, the 0.7s would cancel each other out. Can we do that? Can we just cancel the 0.7s? The answer is no. If we do that, we'd say, oh, that cancels with that. But to do that, we'd have to divide that one by 0.7. So all of a sudden, if we multiply all the gammas, all the sigmas by 0.7, this probability term changes. It has the same effect as if we divided 3.025 by 0.7. Okay? The same thing will happen with this probability term, too. Actually, all we needed to do is, if it happened with only one, we would not be able to do that same trick. Okay? So we can't do that same trick to say that the sigma is not identified. In fact, it is identified. If we multiply all the parameters by the same constant that changes the likelihood function. Therefore, there is going to be a unique value, a unique values of the gammas and the sigmas that optimize, that maximize the likelihood function. Okay, now why was that? The answer had to do with these 3.025s. The fact that we estimated, if instead we had just called them thetas and said we're going to estimate theta, we'd be back at the same situation where we'd say, no, sigma is not identified. But we actually know the thetas. How do we know them? How does Krehbiel and Rivers knows them? They did a special trick. They read the bill. They read the actual amendments, and that's where they got 3.025, 3.1, and those two numbers. Okay, so because of that, that's why we don't face that same problem that we do with the probit, and so we don't have to worry. The sigma is identified. Okay, and let me discuss. Okay. I want you to read Krehbiel and Rivers, what they write on page 1158. Okay, they write something that if you hadn't had what you've learned in the last 5 weeks of this class, this passage that they wrote, I think would sound just incredibly cryptic, and you'd have no idea what they're talking about. So I wrote it on my notes. Let's see, rather than write it again. Okay, here's what they write. And by the way, I'm almost certain Rivers wrote this. I'm not sure he's as good at. That guy's really smart. He's not always good conveying what's in his own mind. Sometimes he's too smart for his own good, and this might be the case here. This passage is so cryptic. Okay, they write, the present situation is distinguished from the usual probit case by the fact that if the bill locations are known, then the parameter gamma is identified. If the bill positions are unknown, then we are back in the customary position of not being able to estimate gamma only up to a multiplicative scale factor. Okay, if you hadn't had the last 5 weeks, you'd have no idea what he's talking about. The idea of estimating gamma up to a multiplicative scale factor, that's the idea of that you can only say what gamma divided by sigma equals, okay? That's what he's saying here. And then the other thing he said, the present situation is distinguished by the fact that if the bill locations are known, okay, those are the thetas. The thetas are known. And it would have been so much easier to understand if he would have explained that. Just said theta. We understand. We know what the thetas are. And then maybe put in, why do we know what the thetas are? What special trick did we do to estimate those thetas? Our special trick was reading the bill. This is something very few econometricians in the past have done, or actually read the bill. So I call that an innovation, that they read the bill. Okay, so by that, they've created the likelihood function, and it is identified. Okay, what do I want to do? Let's see. I'll come back. So in this segment, okay, I'm going to come back and explain what we've just done, by the way. What Krehbiel and Rivers have done is an ordered probit. Okay, the likelihood function we created is an ordered probit. Now, it's a little bit different from the usual ordered probit, because in the usual ordered probit, you don't know the bill locations. Okay, and I'm going to explain that in the next segment. And I think I'm also going to talk about the actual estimate of sigma, and something a little bit about the substance of what this means for congressional scholarship. That is the Krehbiel-Rivers paper. Okay, I'll do that in the next segment. See you there.